Hello and welcome back to the channel, and today we will be recreating Crash the Castle in Godot. I've had a lot of fun playing this game back in the day, and I don't think it would be too hard. I wouldn't make as many levels as this game, but it would be fun to make because yesterday I got absolutely crushed by Godot's rigid bodies, and rigid bodies are what we're going to use. Here's a little infographic for what the game is going to look like. Essentially everything in the game will be a rigid body. The rock that we're throwing is a rigid body, and we will apply an impulse to it depending on the angle of the trebuchet. It's going to be a trebuchet game, not a catapult game, by the way. Trebuchet, superior siege engine. Depending on the angle we will apply an impulse going in that direction, this direction, this direction, this direction, and we'll send this. And once it collides with one of these, it will apply force to them, so they will in turn fall onto the people over here. So let's look at the game itself. Ta-da! So everything, as you can see, even the little humans inside are kind of rigid bodies. Obviously this is not made in Godot, but the basic idea is very similar. Now what I'm not sure about, the only thing I'm not sure about, is the little humans. They don't die on contact, but rather it seems that they die once enough force is applied. So I will need a way to track the amount of force applied to the enemies. So let's start with the trebuchet. I've actually made a game similar to this in the past. Well, not really a game, this was just for a tutorial. But essentially, this is a rigid body, and on right click, there's an animation that goes back, goes forward, and launches a projectile. So this is basically what we'll use. This is made with Godot's animation player, and once we click once, it's playing an animation back. Then after that animation is done, it's playing an animation forward. And once we click within that forward animation, it launches a projectile. And I will link in the description to the video about this specific part of the game if you're interested in that, but we will just steal this. So here's what we're starting with. So the code itself has like movement in it, so we'll be getting rid of that because that was supposed to be like a moving trebuchet game. The rock, we're loading a rock. When we're shooting, the rock is just a rigid body. It doesn't have anything on it. So now we will be making more rigid bodies. Another beauty of this game will be that we don't really need to draw animations. Everything is just one sprite, like in the original, which I appreciate. I like being lazy. Collision shape 2D. We'll draw some wood planks. Let's drop some wood planks, shall we? See how this goes. Ooh, okay, alright. Alright, I like this game already. Okay, so this will be our king. Crypts. So now is the moment when we figure out how to kill them. So let's see how these work actually. Kill him, yes. Okay, so the king got hit there, but he didn't die instantly. I don't know, his velocity changed too fast? Is that what it was? I'm not sure how. I'm kind of wondering if there is a way to get collision information, which again, I am not sure about, because I'm not very knowledgeable about rigid bodies. This is why I'm doing this. Integrate forces allows you to read and safely modify the simulation state of the object. direct body state. Okay, so this is what we can get. We can get angular velocity, inverse inertia, inverse mass, velocity at position. We can do this. Returns linear velocity vector at the collider's contact point. This is what we're gonna use because the velocity vector, I believe, would allow us to, so either it's relative velocity, and in which case we just check whether it's high enough. In case it's relative velocity, that this thing returns get contact collider velocity at position, which I'm not sure, velocity vector not relative or what. Or if it's not relative, then we get velocity collider and get velocity of self, and essentially from these two we can get relative velocity, and if it is high enough we die. If get contact count is more than 0, let's start out with this and drop our king over here. Stop it. Get contact count integer, but it printed this. Interesting. Now what is it printing even? Literally stupid. I forgot. That was my own code. That was my own code that I was printing. Contact monitor on. Contact monitor on. Do we need both of them on? I don't know, but we about to find out. Nope. As bodies are configured to monitor contacts. Contact monitor. Oh, contacts reported. Alright, what's it in contact with though? Oh, it's in contact with the 4. I see. Okay, that's fine. Now, the question is, if we turn off the contact monitor for this one, will the king still track the contacts? It does, okay. So we don't need contact monitor for this at all. I'm wondering how we would iterate through every contact. Get contact collider velocity at position. And then let's do 1 and 2. Okay, nice. We would get the magnitude of this vector, and we would make sure that it's greater than, I don't know, 20, and we would iterate over every contact while I is less than states get contact dramatic death velocity vector 2. Let's be accurate about this. 30 death speed less than contact velocity length. What happened? Oh. Alright. Moment of truth. Boom. Wonder if it's 50. And at 100 it's not supposed to work, I don't think. Yep, okay. And now let's see if the guy falls. Boom, boom. Okay, that was not supposed to be like that. I don't think. What if we make it less? He was supposed to die. The velocity is not relative, it's just the velocity of the collider. Which I mean makes sense, because contact collider velocity at position. Yeah. So how are we gonna fix that? Contact velocity. That is worrying. We know the speed of the thing that's colliding with us, but we don't know our speed on contact. I definitely see a way of finding that out by making the 4, everything a rigid body, the 4 included, switching the 4 into static body mode, and then getting the velocity of the king from that other body, but that seems like too much work. So we're going to have like kind of a hack implementation here. So there are two options: either something collides with our body and we know this angle, this velocity, or we collide with something and we don't know this velocity. The way that we kind of find this out, especially on collisions with the 4, is we save the previous linear velocity, and then on every process, or whatever it's called, the one on every integrate forces, we can compare to the new linear velocity and find out delta velocity, which should be a huge jump, greater than death speed, or contact collider velocity is greater than death speed. And in neither of these cases, we die. Boom, boom, yes. Okay, now how high can he go without dying? Will he die if he drops from this height? What happened there? Still died. Alright, so let's increase the death speed to 50. We want to build a system for making levels. And the way we are going to do that is we are going to have a game script that is the same for every level, and we're going to switch from one scene to another on a level switch. So that's what we're gonna do, and we're gonna have projectiles are followed by the camera. So we're gonna do that, and the way we're gonna do that is we're gonna attach a camera to the trebuchet. Once it launches a rock, we will tell the camera to follow the rock instead for a little bit. And then once the rock reports a hit, so once it landed, we will wait for a little bit and then go back to the trebuchet. So, alright, so what we're gonna do now, because I'm blanking out on the camera thing a bit, is we're gonna draw ground sprites. That's what we're gonna do. Remove this static body. I'll add a tile map. Oh, that's ugly. Why is that so ugly? No, that's so ugly. I didn't make it properly. Ooh. That's unfortunate. Kind of, not really, but still better than freaking lines on top of it. Still can tell there's a tile set though. Let's go back to the game. Let's move the camera. Which is current. And it should go now. It's not going. Interesting. Target no, following true. Let's stop printing all this stuff, actually. We don't need it anymore. It's just annoying. Right about now. Okay. It's not auto start. That's fine. Let's slow it down a little bit. Doesn't need to move that fast. Node camera 2D target equals instance. 3 seconds. Timer start. Target equals get parent get node. Trebuchet. So I'm thinking for this game, we actually need a separate game controller node, which is kind of weird. Well, I mean, I've never done it. So game controller will be a node, just a node 2D. Actually, could be a node, doesn't matter. We're just using it for its script. Not even game controller, just level info. Keep the amount inside it. We will have a node with an export var enemies. Oh, this is kind of pointless. I can just add an export var in the game itself, right? I just haven't done that before. And then we can change it and have different levels, right? Okay, yeah. So I was just brain fart. Because we will have like a different amount of enemies on each level, so ideally we don't want to have different scripts for each level. We will just have the same script and do everything inside the editor, just for convenience sake. And then we'll have a next level, export var next level. There we go. It'll be so easy. If die get parent enemy dead. 1. If enemies less 0, scene to next level, and add a label to the center of the, and then align center. On timer timeout, we will change scene to this and label visible. Timer start and camera to canvas layer visible equals true. Okay, it's way off. And then mover level complete. I'm actually not sure how to even go about fixing that, but we'll keep our label over here and we will move our camera back. We want some particles, some bloody particles. Gravity, we'll set gravity to like 1, and then time 1 shot. 0.56. Velocity even more, 40, and then lifetime 0.5, and then gravity 40. Shout note timer. So it'll be our death timer. Timer start. Sprite visible equals false. 2D emitting equals true. Active equals true. Equals false. Should wait. So basically what we're gonna do here is make sure that the trebuchet can't launch while we're not actually looking at it. So we're gonna this is gonna wait until we get back to the trebuchet in the first kind of sequence of camera being at the castle and then going back, and then we will set active to false when we switch from the trebuchet to following the rock. And then once the rock switches the target of the camera back to this, we will start this timer. Okay, let's add a label to this duplicate. No, we won't even duplicate. Add child node label. No, we will duplicate because we're lazy. Level complete over here. Shots left. Game shots left -1. If shots left less than 0. When we fail, we're gonna just tell the player they need to press R to restart. Level visible equals true. Restart. Start visible equals true. Action pressed. Restart. I think we're going to start making the levels. And then once the levels are done, we are done. So we do want the camera to move faster after it's done. Okay. This. Pardon my French. No, I want less of them, not more of them. probably because I didn't change the amount of enemies. So this level is doable, and we will do 2 more. Okay, why is level 2 getting messed up? What killed them? Who shot you? Okay, it's done. The game is done. Officially done. Woo. Oh my god.